Hello and welcome to another video. Today we have an MSI B550-A Pro on our bench. And it's from a viewer. It says right here, beware, starts without CPU but has weird on-off behavior. Because this has a weird power behavior, I would expect that there might be a short circuit and there's some protection feature going on here. So we will start with our usual checks. Black probe onto ground, and after our ground, let's check on our 24 pin. We start at 3.3 volts right here, and that has very low resistance. Okay, first measurement already great. Okay, let's see, 100 ohms would be fine. 4 ohms, yeah, we have a 3.3 volt short. Okay, first line already that we know that is shorted, great. Especially 3.3 is a voltage you don't want to see shorted, because that is mostly related to logic parts and you don't want that shorted. Let's continue with 5 volts and 12 volts. So 12 volts right here, kilo ohms, and 5 volts right here, 800 ohms. Okay, we can also check 5 VSB. Also 800 ohms. Okay, 5 volts and 5 volts VSB has very similar. That can be true. So let's check then the 12 volts for the CPU that comes in here. So we check the pins, and that is fine. And we take the upper one that has the latch right here. If I could get proper focus. We take the upper one where the latch is, and then we check to the CPU face right here. And that has also high resistance. So that is also fine. Okay, so we have a 3.3 volt short. That is bad. So we will have to start with that without putting any power or processor in here. We need first to find out what the 3.3 volt short is coming from. So what we're going to do, let's take our lab bench power supply. And at my lab bench power supply, you can now see that I have voltage. But we're going to go with lower than 3 volts. We're going to start with 1 volt. We have 105 volts. Let me get something that we can inject voltage now with. So the current setup. One is connected through ground, through an USB port. That is our ground. And then we have the other one going to this cable clip. And I will be attaching that to this pick. Now let's take our thermal camera. We have no current limit set currently. So let's see right now what it will be. We have 240 milliamps. Yeah, I can already see it. There's one thing right there. If you have a look there, the SIO is getting hot. And let's get the macro lens onto here. And this is where we're going to look at, and injecting 3.3 volts. You can see 250 milliamps of power consumption. And that is with only 1 volt. If we now go to 3.3 volts, that actually should be there. We have 1.1 amp, and it's now glowing hot. There's nothing else on the board anywhere, but only the SIO that is damaged. We have to change out this SIO. So let's have a look at it under the microscope. So this SIO blew up violently. There's actually just a hole in here. Let's see. We have an NCT 6687D. 66870. I have these in stock. Thank God. I have 2 more of these. Very, very good. So we can change these out instantly. And yeah, if we take tweezers and let's see if we scrape at that, if this actually, yeah. There's multiple places that this burned through. There. Yeah. Really blown up SIO. Well then, let's prepare to take this off. And now the board is on its preheater. As you can see right there, there's the preheater. And now I will be replacing the chip. First, what I do is I tin all of the pads. I put leaded solder on all of them, put a lot of flux onto them, in order to easily remove this chip, because this chip is very toast. So all what I'm looking for is to tin all of the pads, kind of like that. Get leaded solder onto them and make sure that also the pins are at the bottom, have leaded solder. Kind of like that. And now I will go all around and do that for all of the board everywhere, so that the SIO removes easily. So today I will be trying it a little bit differently than I usually do to remove these. So not the actual removal, but the part of soldering a new one on. Usually I take these off and then solder the new one in by soldering each individual pin. But today I want to try if I can actually do it with hot air and make it faster that way and actually make it reliable. So I'm blasting the chip now. Cannot grab it. Let's take different tweezers. Right there. Now I got it. Hopefully nothing got destroyed. So it all looks fine. What I will be doing now, let's go under the microscope. So now I will be still removing all of the old solder, because it's all non-leaded solder. And we want it to have a lower melting point so we can solder it easier and better. So applying flux all over the place. We take our braid and our soldering iron and get them all very clean, as you can see. So now it's completely clean. And now what I will be doing is first we clean up everything. So we want to get rid of all of the burned flux. And now it's very, very clean, as you can see. We have a great setup now for getting the new one on. So we start off again with using flux. We get a good amount of flux everywhere. And now we're going to be tinning our soldering iron, and we're going to be applying leaded solder, clean leaded solder everywhere. So, and when you have bridges like that, it's because probably your soldering iron is very hot, like mine, and it burns the flux off instantly. So I will be setting my soldering iron a little bit lower in order to not burn everything so fast. And that looks fine now. Let's see. Here we can add some more. And now it looks better. The reflections are still quite much with this flux, with this gel flux that I have, but it should be fine. So let's get the new SIO onto here. And usually I've never done this method before of hot airing it on, because I've always went just ahead and put it on each pin to be safe and that I have a good orientation on it, positioning on it. So this will be something new for me as well. So let's get it very roughly into position. So now the chip is roughly in position, not quite, as you can see by the left side. Let's nudge it a little bit more. But this is the point where it's harder to position it, because we have solder on our pads everywhere. Now it's very nicely on there. I want to try to pin on one of the pins, so I can basically instantly blast it with hot air without it flying away. So all I want to do is... Okay, this didn't want to attach. So this is now on. So with hot air, I will have to look way better at that the chip positions correctly. So get a good amount of flux onto here. And let's now get hot air into here and see if we can put this SIO onto here. So let's see here and try. So this is supposed to be on right now already. Oh yeah, It is off by 1 pin at least. I have to push it a little bit further and do that again. Okay, big learning curve here. So the SIO is now on, and the orientation is fine. It's not great, but it is fine. But I don't think it's set properly. So I think it sits on top of the solder, but isn't actually soldered. Let's see, yeah. Exactly like this. This is my problem. I've even pushed down on the chip, trying to circumvent this. But exactly this is my experience that I have with trying to hot air these chips on. It's just that they don't go onto the solder very much. So at the end, we still have to take our soldering iron and drag these on. So I will be doing some drag soldering in order to put these on properly. So this took way longer than the way I usually do it, because the SIO just wouldn't sit flat, and soldering the pins on then made it a lot easier like it was. But I think it's on now. I don't have any short circuits anymore, and I think it's connected everywhere. And yeah, so that method was a fail for me, that most definitely. And I also had to replace that capacitor, but that didn't have to do anything with that. That was just me knocking it off while trying to solder these pins here. Let's then see if we still how the resistance looks on 3.3 volts and get on with this repair and hopefully finish it here, because this took almost an hour. I think this took like 45 minutes to solder, which is way too long for just an SIO. So let's see for the resistance now. We go on to ground again. And now we can see we have a kilo ohm of resistance. That is very good. So let's proceed with putting a processor into here. We're going to put RAM into here. We get a power button and a speaker onto here. I'm gonna be so bold and already put a cooler also onto here. So we have debug LEDs right under the 24 pin right there. So let's see for its passive power consumption then. And passive power consumption, 430 milliamps. That is very high. That is not good. That is really not good. Do we just push the power button? Let's just push the power button and see how this behaves. Okay, we do not have a reaction to the power button. So I thought so. We will have to look at this with the thermal cam once more, because there seems to be more broken. So let's see. We are going to be turning this on, and I can see two things heating up a lot. There's the 3.3 volt VSB regulator, and I think it was the Ethernet chip. So let's check for the resistances there. Go under the microscope. So this right here is the 3 VSB regulator, and let's check its output for a short circuit. 10 kilo ohms. Really, because this I think is its output. No. Okay, that was something else. Okay, so let's see then. We have 19 ohms, 18 ohms, 19 ohms on here. Okay, so we definitely still have a short on 3.3 volt VSB. So, injecting voltage once more. We're going for 1 volt again. And it will, I would guess that it will probably be the Ethernet controller then that is shorted on here. So let's see right here. I think it will be the Ethernet controller. So let's inject 3.3 volts. That is very little power consumption actually. So we will have to go for 3.3 volts actually on here. Yeah, it's the Ethernet controller, as you can see right there. The Ethernet controller is heating up. So we will have to go under the microscope and remove that. So right here, we can see the Ethernet controller that is getting hot. And yeah, it looks fine visually, not like the SIO was. I would normally apply leaded solder around it to make the melting point lower, but this has a big ground plane under it, so using leaded solder wouldn't even make a difference here, because we would still need to get the point below it molten. So let's remove this. And there it is off. Let's clean up the solder points here, so that we don't have any short circuits here. Just like that. Now the area is cleaned up and it's removed. And the good thing is, we don't need this to start up the board, because the Ethernet is optional. So let's check for the resistance here once more. So once more, resistance check, 3 VSB. And now we have high resistance, because that was my 200 ohm range. Let's go in a 20k ohm range. Yeah, even 20k has high resistance. That is very good to see. Now it's displaying properly 1.1k ohm. That is very good. So let's check without the Ethernet controller now. Passive power consumption. 250, still a little bit high, but it should be fine. Let's hit the power button. 1.6 amps, CPU LED. That is a very good sign so far. But that seems like our BIOS isn't initialized. Let's see with a different CPU, because the CPU might not be supported. So let's go with the 3000G. So let's see once more here. 1.9 amps DRAM LED. Let's see if it goes further. And now stuck on a DRAM LED. Okay, let's see, does it react to the power button to turn this off? Okay, it doesn't. Let's power cycle this and put the RAM into a different slot, just to be sure. So once more reseated RAM. And let's start up again. CPU LED 2 amps. Very weird behavior currently. So while I was looking around, because we got stuck on a CPU LED, I actually found this. This is a fan header controller. Like with every fan header, there's most of the time like one of these Nuvoton chips that you can see right there. And this one looks like it got burned actually. So this might be a problem. So let's check for resistance around here. Do not know which pin should be what here. So let's check all of the pins. Pin 1 has 700 ohms. Pin 2 has high resistance. 3 has high resistance. 4 has high resistance. High resistance. This might be ground right here. High resistance. High resistance. So there's a single pin with low resistance, which is this one, which probably then is the ground itself. But I'm not sure. We might want to check that. So I just checked the board view, and actually that pin right there goes to the SIO that has low resistance right here. So I hope that this didn't kill our SIO in the process, but that it is the chip itself that shows 1 ohm. So let's try to get that chip off of there. And let's hope it didn't kill our SIO in the process. So here we can easily put leaded solder on all of its pads. So all of the pads have leaded solder. Let's see, I want to get a metal bracket in order to protect this fan header at least a little bit. Just like that. And let's try to blast this off of here. So the chip is removed. And let's hope that the resistance now went up here. Oh, thankfully it went up. Oh, that's really good, because Because that could have meant that the SIO got blown by this, but now it isn't shorted anymore. I was already scared to put another SIO onto there, because it's getting late and I want to finish up this repair, to be honest. And I wasn't looking forward to place another SIO onto there. So, let's try this once more. 250 milliamps still. Hit the power button. CPU LED. 1.6 amps. SIO is not getting hot, but CPU LED is not moving. Okay, let's try a different processor just once more, because I went to the 2200G again. So, 3100 in here. CPU LED. And not moving any further. That is not great. Let's see if our DDR voltages are there. So, putting in our RAM tester. And let's see, all of our RAM voltages are there. So that is not the problem, but we're still stuck on reset. So I will be now looking around for more damaged components. If I don't find any more broken components, we need to take off this BIOS chip in order to check that the BIOS is proper on there. I found yet another component that seemed to have blown up here. This is a diode. Let's see for its resistance here. Yeah, probably also 0 ohms. 63 ohms. Pretty sure that this is dead. Because you can see flux coming out of there, and that probably means that it got very hot. Let's remove this. Let's put leaded solder onto here. Yeah, and this thing just peeled off, as you can see. It just completely burned there. So I didn't even need to take hot air, because this was just completely broken. And there the diode is removed. Let's check the resistance again. And resistance across it seems to have increased. Yep, we now have really high resistance here. Big question is if we need this diode. I'm not too sure. I've never had this diode fail. We might be needing that diode for this chip to work. But let's see without it. Because on the Ethernet chip and on the fan controller, I knew that we didn't need that. But here I'm not too sure, to be honest. Let's have a quick see under the board view. So right here in the board view, this is D52. Oh yeah, this takes 12 volts into here. Okay, so for this chip, in order for this chip to run, we need 12 volts. Yeah, we will have to replace this diode. 1N4148W. Okay, so let's get that LED then. That diode in order to put that in. So I got a different diode and I have no idea in which way to put it in. So we're going to have a good look here how this works. So let's see for this diode, for example. I probably want it to read 069 in this direction, okay. And in that direction it reads the same. So let's see then. It needs to go into that direction. And that has this stripe. So probably around this way, I would say. Let's try that. So this is a little bit... the package is a different one, but this is actually the exact same part number. So let's see that we put this on just with the soldering iron here. Not great, but that should do. So not pretty, but I just want to see if this can make our board boot now. So let's see right now. Let's see for our passive power consumption. 250 milliamps still. Let's see then. CPU LED 1.6 amps. So we do have different power consumption, but we're still stuck. I cannot believe this. What is wrong with this board? Probably still something that blew up and that I will have to search for. So it seems to be that I still have a problem with the 3.3 volts. So I will be injecting voltage again into here. And I think the resistance isn't high enough. There's still something that is dead here. So let me try that. So I just took off the heatsink for the PCH and have a good look what unraveled here. I've never seen this. Like, this is straight up blown out here. And that's not the only one. Look at that. And look there. This, pretty sure this thing is dead. Like, this thing probably has gotten its guts blown out. Let's see for some resistances. This is just 11 ohms at this coil, which is very low. Usually this has higher resistance. So this is the one that has 11 ohms. And let's check right here. But this has very high resistance, 1.3 kilo ohms. Like, this is very weird. Oh yeah. Ha! Look at that. I've never seen that happen. The actual pad is blown off of here. It just instantly moved. Let's see for its regulator, I think, which is this one. But the resistance here looks fine. And because this is the feedback as far as I know. But yeah, that resistance here is way too low. So yeah, all of our efforts, sadly, were for nothing. Because pretty sure this thing has a dead PCH or FCH, what it's called. And look at all of these places. These are so charred. I've never seen an FCH behave like this before. Where it's blown out like this at some places. Where it got so hot. Let's see. What resistance is this here? Is this... This has 0 ohms right here. Let's see in the board view what this is. So the other side is ground. So that is supposed to be low resistance. But let's see in this side. This side has low, higher resistance. But I don't get a reading, for example, here anymore. Pretty sure that this is just a goner. Like, look at how many places this happened. Where it got this hot. This is ridiculous. I've not seen anything like that before. And yeah, this 11 ohms at this coil is way too low. So I just had a look at a board that actually works. And it has 20 ohms on that line. And that doesn't seem to be too big of a resistance change, but it probably is. I want to see, while it's working, actually, I want to see if the resistances get pulled low too far. So we're now in passive power mode, power consumption, and now this explains it very well why we had 250 milliamps, because the PCH is heating up way too much. Let's get the light off of here for the reflection. You can see right there, it's heating up. The regulator is heating up, and the 3.3 volt is heating up, because that also goes into the PCH. So yeah, this board is too far gone for me to repair. This already took so long. I already put a new SIO into here. That SIO could still be taken off. That is no problem. But that PCH, FCH, that needs to be changed here. Ethernet controller, the 12 volts for the fan. Oh, like this is a big... this is a board that I won't discard as a donor, because I want to put this to the side, and at some point I will try to replace this FCH. But for now, this is how far we gotten. This took so much more time than I anticipated. I really thought after replacing that SIO that we will be done. But yeah, far from it. So this board will need a lot more attention. But I hope you learned something today. You enjoyed the video, could follow some and learn something from it. Thank you very much for watching. This was Mainboard Medic. Thank you very much and goodbye.